Hi guys, I will explain the moment of area part 8 from special case of Mohr circle to summary. Here I have a quiz for you. In the following equilateral triangle, there are two coordinate systems, zy and z prime y prime, passing through the centroid. Which is the correct product moment of area about the two coordinate systems? In the previous videos, I explained all the contents from first and second moment of area to the arbitrary rotation of a coordinate system or cross-section and how they appear in the Mohr circle. In this video, I will explain the special cases of a Mohr circle and application example of Z-channel. As a special case, if the second moments of area with respect to two axes passing through the centroid equal to each other and simultaneously product moment of area also equals 0, then the radius r of Mohr circle becomes 0. Thus, Mohr circle becomes a point which is not a circle. Let's call this Mohr's dot. Let's find out which cross-sectional shapes correspond to this. A circle has the same second moment of area and the zero product moment of area with respect to any coordinate system with its origin at the centroid. Therefore, all the axes passing through the centroid are principal axes. Similarly, equilateral triangle also has the same second moment of area and the zero product moment of area with respect to any coordinate system with its origin at the centroid. Therefore, all the axes passing through the centroid are principal axes. The radius r of Mohr circle equals 0, and the Mohr circle becomes a point which is not a circle. Every regular polygons has the same second moment of area about each axis with respect to any axis passing through the centroid. And all of those axes have a zero product moment of area. The radius r of Mohr circle is 0, and the Mohr circle becomes a point that is not a circle. Therefore, product moment of area with respect to any coordinate system with its origin at the centroid equals 0, and all the axes passing through the centroid are principal axes. Those characteristics are commonly applied to all the regular polygons such as regular hexagons, regular heptagons, regular octagons, and many more. If the cross-sections of each quadrant are of the same shape and all diagonally facing cross-sections are point symmetric, the entire cross-section has the same second moment of area and zero product moment of area with respect to any coordinate system with its origin at the centroid. Therefore, all the axes passing through the centroid are principal axes. The radius r of Mohr circle is 0, and the Mohr circle becomes a point which is not a circle. As a practical example, let's calculate the second and the product moment of area for an actual Z channel. The first step is to divide the entire shape into easy-to-calculate shapes. Let's divide the channel into three rectangular shapes, A, B, C, as shown in the figure. In the second step, calculate the second and the product moments of area about the local axis passing through each centroid and parallel to the reference axis. The product moment of area of each rectangle is 0 with respect to the axis passing through the centroid. In the step 3, we calculate the second and product moment of area for global coordinate system. Using the parallel axis theorem, we can calculate the second moments and the product moment of area with respect to the global axis z prime, y prime. For example, using the parallel axis theorem for the cross-section A, all the moments of area can be calculated as shown here. Now we can calculate the second and product moments of area for global axis. Since the centroid axis of the section B is the same as the global axis, the same value can be used as it is, and the section C has the same value as that of section A because C is point symmetric with A. Therefore, by summing up all the values per global axis, z prime, y prime of ABC, the result shown in the table can be obtained. As a step 4, draw the Mohr circle and find the direction of principal axis. It is not necessary to draw the Mohr circle to find the direction of principal axis, but if you draw the Mohr circle, you can fully understand the overall characteristics of the cross-section. The radius r in the Mohr circle has direction and size. The horizontal component of point z prime, which is the end point of radius r, represents the second moment of area with respect to the horizontal axis, and the vertical component represents the product moment of area. Y prime represents the second moment of area with respect to the vertical axis. In the step 5, by calculating 2 theta using the geometric properties of a right triangle z prime AO, the angle theta from z-axis to the main axis can be obtained. It is also possible to calculate directly from the related equations without using the Mohr circle. Let's check whether it is consistent with the calculated value using the Mohr circle by calculating directly with the related formula. Since the product moment of area at the principal axis equals 0, by substituting 0 into product moment IZY, the theta representing the angle to the principal axis can be obtained. It can be seen that this value is the same as that obtained by Mohr circle previously. By substituting the previously calculated theta value into these two equations, we can calculate the second moment of area for each principal axis. These two values are the same as the result calculated by Mohr circle. The direction of the angle from reference axis to the principal axis in the actual section is the same direction as those in the Mohr circle. The size is half of the angle in the Mohr circle. Now let's calculate the second and product moment of area of Z channel and the angle to the principal axis when the positive direction of horizontal axis is to the right instead of to the left. If you calculate them in the same way as before, you can get the results shown in this table. The difference from the previous results is that the sign of product moment of area is negative instead of positive. This is because, as shown in the figure on the left, the areas of second and fourth quadrants are distributed far and a lot from the origin. The difference between the Mohr circle here and the previous one is that the direction of increase of the second moment of area is directed to the right in the same direction as the positive direction of horizontal axis defined in the actual section. Since the product moment of area is negative, the final value of theta is positive. The radius r of Mohr circle has direction and size. The horizontal component of point x prime, which is the end point of radius r, represents the second moment of area with respect to horizontal axis. And the vertical component represents the product moments of area. Y prime represents the second moment of area with respect to the vertical axis. By calculating 2 theta using the geometric properties of a right triangle x prime AO, the angle theta from x-axis to the principal axis can be calculated. The direction of the angle from the reference axis to the principal axis in the actual section is the same direction as those in the Mohr circle. The size is half of the angle in the Mohr circle. The answer to the quiz is number 1, because for the polygons, the product moment of area equals 0 in the coordinate system with its origin at the centroid. Here we have a summary. If the second moments about two axes passing through the centroid equals to each other, and the product moment of area is 0, then the radius r of the Mohr circle becomes 0, and the Mohr circle becomes a point which is not a circle. These characteristics are commonly applied to all the regular polygons. For the rotated coordinate systems, the second and the product moment of area can be calculated by either Mohr circle or related equations. The direction of the angle from the reference axis to the principal axis in the actual section is the same direction as that in the Mohr circle. The size is half of the angle in the Mohr circle. If you watch the previous videos, you can easily understand the upcoming videos. In the previous video, E46, I explained how to draw the Mohr circle step by step. Recently, I explained the arbitrary rotation of coordinate system or cross-section. Next video will be Fly Steer Part 21, Moment of Area Part 10. I will explain how to calculate the second and the product moment of area and how to draw the Mohr circle for the real tire parabola. Please hit the thumbs up and catch the brand new videos by free subscription. So, what are you waiting for? See you in next video. Goodbye guys!